is on the ethics of autonomous vehicle testing. Now, there's plenty of buzz these days about self-driving vehicles, what the future may look like with so many of them on the roads. This multidisciplinary team combines health policy analysis and civil engineering to step way back and ask how these vehicles should be tested and deployed. The team, as they started their project, quickly saw how industry is at the forefront of these discussions, and they connected with the players in the industry. They were selected to speak at a very influential Automotive Safety Council general meeting. They put ethical issues on the table in a place where they're not typically voiced. And they've learned that long-term, this is all about building relationships and trust between public health and industry, at least up to a point. Therein lie perhaps some ethical questions. Over to you guys. And I'm going to ask each presentation team to introduce themselves by name.
My name is Johnathan Ehsani, and I'm Igusa from the Whiting School of Engineering. And we'd like to just begin by thanking the Practical Ethics Initiative, because it was literally the spark that began the collaboration that Tak and I have forged together. If it wasn't for this initiative, I would not know this man. And I've told others, and I'll say it again, because I'm maybe embarrassing him, that he's the best thing that's ever happened to me. Because when an engineer is able to understand people from public health and then take the time to kind of listen, understand, and figure things out together, remarkable things happen. And I think it was it was absolutely the requirement that at least 2 schools be submitting proposals that kind of what sparked that collaboration. So anyway, so thank you, and also I'd like to acknowledge Nancy Cass and Govind Prasad, who was a former colleague of ours, because they've been also instrumental in helping us think through the tricky questions and will continue to do so going forward. So getting right into it, sorry I've lost a minute already, but I'm going to talk a little bit faster from now on. So ethical questions about autonomous vehicles, we were kind of surveying the literature, the popular media, and we saw a preoccupation with what is called the trolley problem. I don't need to explain this to the people in the audience, but basically it's a interesting and intellectually very kind of tough, but what I would describe as a kind of a peripheral ethical question about autonomous vehicles. Yes, we should program the vehicles in a way that maximizes, life and minimizes harm, but our view was that actually there are much bigger ethical questions that we need to lock horns with. And this one, while it's intellectually engaging, should really fall to the wayside to kind of give way to bigger questions. So today, because of the limits of time, we're only going to cover 2 or 3 of those big questions. And so I'm going to basically hand over the first part of the presentation to Tak, and then I'm going to take over at the end.
So this is something we presented to the NTSB. They're the ones who investigate crashes. And what we're talking about here is the competitive nature of the industry. And there's a competition between that competition and the safety of the public. And so I'm starting here. So Sebastian Thrun is the one who really started the revolution in autonomous vehicles. And this is, I quoted here because this is something that really the industry should listen to. And that's when a self-driving car makes a mistake, everyone should learn from it. Okay. And I want to back this up with some empirical evidence. So what I'm showing here is a curve that we use in engineering. It's basically the learning curve. So the horizontal axis tells you the experience of a fleet. Now, if you're looking at competing industries, one fleet is one car company. Okay, so you can think of the collective experience of one company. And the vertical axis is called mean time between failures. But in this case, it's as a failure is disengagement, so that's the technical part. But just think of the vertical axis as representing safety. So the higher you're up, the more safe your vehicles are. And the learning curve theory just says that it goes up in a straight line. But what's more important is that the two axes are logarithmic. So, and I'll show you the data in a second. So logarithmic meaning one step up and you increase safety by a factor of 10. Okay, so here I wanted to show some of the evidence here. So these are 4 major autonomous vehicle companies. And you can see indeed that if you track the experience, so each of those companies has their own fleet experience. And since they are competitive, they don't talk to each other. And what happens is that each one of them has their own curves that they track. And you can see here the bottom axis, that's in thousands. So the left axis is 1 million vehicle miles. And vertical axis, you can see the log scale. So you can see that blue curve, which represents cruise VM, went up by a factor of 3 orders of magnitude. So it's 1,000 times more safe over this fleet experience. Now, these aren't the only 4 companies that are competing. There are a lot more. And you can see here, it's basically the mess. And what it is a lot of these companies on the lower part, which is the unsafe region. So they're lower in the vertical axis, and they're towards the left, showing inexperience. And they go hand in hand. And our point here is that really, if you want the industry to move forward so that they can introduce these vehicles into our streets, they really should do data pooling. And when we presented this to the NTSB, they gave us, they talked at length about what they've done in the airline industry, where they do indeed pool data together. Even though they're competing companies, they pool data, and it has done remarkable influence in reducing accidents in airlines.
Thank you, Tag. So that was just another remarkable example of how engineering and public health can create really amazing graphs like that. So the next ethical question is really one that we experience across a range of technologies. I'll give you an analogous example. If you're developing a pharmaceutical product, and you're developing it on, if you're testing it in a certain demographic of the population, then that drug, in theory, becomes more suited or more suitable for that population than necessarily for everyone in the population. And that poses a question, is that right? Is that fair? Should we be doing that? And autonomous vehicle testing has some analogies to development of pharmaceutical products. And we asked ourselves, let me take a step back here. We cannot overstate the competitive nature of the autonomous vehicle industry right now. When companies say we're not going to share data, they're not saying it like with a smile on their face, oh, we're not going to share. They are basically so secretive that when one company is testing their vehicles, there's a line of cars behind that test vehicle, video recording what that vehicle is doing, and they're all the competitors, seeing what that vehicle is capable of doing, and can it make a left turn, can it not make a left turn, and so on. So all of those become competitive data points for the companies to see who's doing better and who's doing worse. And so, of course, these companies are not going to release the routes that they're testing on. They're not going to say, I drove down 85 and I made a left on, they don't release that. California Department of Motor Vehicles requires them, though, to report where they crashed. So, if you go on the California DMV website right now, you Google autonomous vehicle crashes, it comes up with every single crash that's ever happened. And we made the leap that we do often in transportation research, that where you're crashing is where you're driving. So basically, if you've crashed there, it means you've driven there. Probably you've driven in other places, but it's basically representative of your exposure. That's a kind of a technical, safety term. And so we said, okay, so where are they crashing? Can we plot them on a map and see what are the characteristics of those neighborhoods? And so we did this, and we saw that, well, there were two, these maps are a little small, but the one on the left here shows kind of roadway conditions. Let me tell you, the green, the very light green, are the geolocations of the crashes. So you can see they're kind of in 2 clusters. And the brown kind of denotes roadway conditions, so infrastructure. And on the other map, you're looking at the density of the African American makeup in the population. And so what this showed us is that, well, testing is taking place in very specific neighborhoods. And we don't know why, but it could have to do with the infrastructure being better or worse in those neighborhoods, or it could have to do with some bias in the minds, maybe not even conscious bias, in the minds of the developers who are testing in certain areas versus others. And then of course people say, well, where we test is not where we're going to deploy. We're just kind of, we're just seeing if these things work, right? But unfortunately, Google announced 2 weeks ago that they're deploying a taxi service in the black area there, exactly where they've been testing. And so the relationship between where you test and where you deploy becomes an important one. And now we're working with a number of cities, including Washington, D.C., to help them formulate their policies so that testing, for example, moves into more equitable spaces. I'll also add that the work that we were able to do here has led to a number of other grants. So we just recently received a pilot award from the Center for Health Disparity Solutions at Johns Hopkins School of Public Health to continue this work on ethical testing, on equitable testing. And we've submitted a proposal to the Robert Wood Johnson Foundation. And we also received a Discovery Award for our work on data sharing. Final thoughts to share with you, and these can be discussed further in our Q&A, is autonomous vehicles represent a fundamental shift in safety technologies. Whereas previously, if you wanted, the regulator would say, you need a seatbelt or you need an airbag, and companies were scrambling to figure out how to put these into cars. Now, safety is in the hands of the companies. And the regulators don't know anything about the technology they're creating. So it creates technical challenges in regulation. This, by implication, means if you want to make improvements in safety, you need to work with the industry, possibly. But as we've discovered, even in the last month within the School of Public Health, we're seeing some resistance to that idea. You must maintain independence. You cannot work with them. And so we're currently struggling with these issues. If anyone has experience or has guidance, we welcome it. And on that note, we'll wrap up. Thank you.